Number 5 is the same kind of problem, just jumbled around things a little bit and changed the values. So here, now they're telling us AC, this side, is 24, and you can see that's the first and the last. And they're going to tell me DC, that first and last. These corresponding sides, DC is 14. And now they're telling me DE, this side here, is 10. And you can see that's the first 2 letters, so AB and DE correspond. And that's a big question mark. I don't know anything about AB. Here they're telling me the perimeter of triangle ABC is 60. And they're asking us to find the perimeter of the other triangle. So I'm just going to compare our perimeters in a ratio. And then I'm going to compare the sides I know. I don't know anything about that, so I've got to use 24. And 24 corresponds to 14. And I didn't talk about it in the other one, but the reason why those sides visually correspond is this triangle here, what happened was it was reflected. It was literally flipped over that line. We could flip it horizontally. So it lands there, and then it was stretched out until it lands on top. So that's why those red sides map onto each other, right? You see that red side? They map onto each other because it's getting flipped. So we have our proportion. Let's go ahead and solve it. We'll get 24x 60 times 14, 840. Divide both sides by 24. X will equal 35, it looks like. 35. And that's the perimeter we were looking for. That's, the perimeter of triangle DEC. We could verify it with the ratio. I'll tell you what, you verify it with the ratio. You calculate the scale factor by using corresponding sides and multiply it by the perimeter. And you'll tell me how we go from 60 to 35. I think that's a nice little challenge.